I'm going to be presenting scenario ASA, or angle side angle. We first begin by solving for the unknowns in the triangle, which are the remaining two sides and our third angle. Our givens are angle A, 34 degrees, side C, 9, and angle B, 87 degrees. The first step is to find the third missing angle. We use the equation C equals 180 minus the sum of 87 and 34, which gives us angle C, 59 degrees. To find the missing side lengths, we use the law of sine, which states that sine of A over A equals sine of B over B. Since we are solving for side A first, we use the alternative formula, which is A over sine of A equals C over sine of C. We then plug in the values, and since we're solving for A, we isolate it by rearranging the formula, giving us the equation A equals 9 over sine of 59 times sine of 34, revealing side A to be 5.87. The same process is used for side B, and another form of the formula is used, which is B over sine of B equals C over sine of C. After plugging in the values and repeating the same steps, we get our third missing side length, 10.5. Now that we solved for all the unknowns in the triangle, we can now find the area. We use the formula K equals half of C squared times sine of A times sine of B over sine of C. The first step would be to find the third missing angle, which we already have. So then we plug in the givens and our third angle, our equation now being K equals half of 9 squared times sine of 34 times the sine of 87 over the sine of 59. We can simplify the equation by finding the sine of each angle. The sine of 34 is 0.559, sine of 87 is 0.998, and the sine of 59 is 0.857. As we continue to simplify the equation, we finally arrive at the area of the triangle, which is 26.4. We then went into GeoGebra to create our triangle based on our given values. So here we have angle A, which is 34 degrees, angle B, which is 87, and side length C, which is 9. And then we put in all the formulas used to find our missing side lengths and our missing angle. So here you have the formulas for side length A and side length B, and here's the formula for angle C. And then we put in our area formula, and it gave us our area, which is 26.4.
I'm going to be presenting for scenario angle side, or AAS. We begin by solving for the unknowns in the triangle. We can start with our givens. We know angle A, which in this case is 35 degrees, angle C, which in this case is 59 degrees, and side A, which is 9. We can begin by solving for the unknown angle. And to do this, we take 180 and we subtract it from the sum of angle A and angle C. In this case, we get 86 degrees. We can then use the law of sines, which states sine A over A equals sine B over B, which equals sine C over C. So in this case, we use sine 35 over 9 equals sine 59 over C, and we solve it for C. So we get C equals 9 sine 59 over sine 35. And in this case, we get C equals 13.5. We then use the law of sines again to solve for side B. In this case, the law of sines is sine A over A equals sine B over B, and we reorder it to solve for B so that it reads B equals 9 sine 86 over sine 35, and we get that B equals 15.7. Now that we have solved for our triangle, we can also solve for the area of the triangle. The area equation in this case is area equals 1/2 A squared sine B times sine C divided by sine A. And we have the givens A equals 35 degrees, C equals 59 degrees, and A equals 9 again. When we plug in our givens into this equation, we get that area equals 1/2 9 squared sine B times sine 59 over sine of 35. We know that B is 180 minus the sum of 35 and 59. So we can plug this into the equation to get that area equals 1/2 9 squared sine 86 times sine 59 over sine 35. And we end up with area equals 120.75 over 2, or area equals 60.38. There are other variations of this formula as well. One is area equals 1/2 b squared sine A times sine C over sine B. And the other variation is area equals 1/2 c squared sine A times sine B over sine C. When we graph the scenario shown in the slides, this is the graph that we get. To show this, we used sliders, angle C, and side A, and equations to show the rest. This is the equation to find angle B, this is the equation to find side C, and this is the equation to find side B, and this is the equation for the area.
Hello. Here I will be presenting the solving of an SAS triangle, or a side angle side triangle. So we will begin this process by solving for the unknowns in the triangle, which in this scenario are side C, angle B, and angle C. Our givens are side A, which is 4, side B, which is 5, and angle C, which is 38 degrees. Since we already have two of our sides, the most logical first step is to find the last side using the law of cosines. The law of cosine states that c squared equals a squared plus b squared minus 2ab cosine c. Since we are solving for side C, we'll use this formula. So this is done as we first plug in our values. So c squared equals 4 squared plus 5 squared minus 2 times 4 times 5 times cosine of 38. So after doing these computations, we get c squared equals 9.48, and now the next step is to solve just for c itself. So we would take the square root of 9.48 and get c equals 3.08. So now that we have that side, we'll use a different process to obtain angle A. This process is known as the law of sines, which in this case is sine of angle C over side C equals sine B over side B. So this is done in our scenario as we plug in our values. So sine of 38 over 3.08 equals sine B over 5. So the first step here is to isolate sine B, because that's what we're solving for. So we would multiply out 5. So it would be sine B equals 5 sine 38 over 3.08. So now after doing these computations, we would get B equals 88.1 degrees. Okay, so now that we have two angles in our triangle, 38 degrees and 88.1 degrees, finding the third is simple. Since all the angles in the triangle should add up to 180 degrees, we can use the equation 180 minus the sum of B and C equals A. So this becomes 180 minus 38 plus 88.1 equals A, which means that A is 53.9 degrees. So when checking that all these angles are correct, we will add up all three angles and get 180 degrees. So in this case, 38 plus 88.1 plus 53.9 equals 180. So now that we have solved for all the unknowns in this scenario, we will now solve for the area. So we can use the formula as K represents the area. We can use the area formula. So this formula is K equals 1/2 AB sine C. So first we plug in the values we've already obtained and get K equals 1/2 4 times 5 sine 38. So after doing these computations, we will get K equals 12.313 over 2. And now we will do that simple division and get K equals 6.156. So that is our area. Here we reflected our illustrations on GeoGebra, making sure they're correct. So first we entered the givens, side A being 4, side B being 5, and angle C being 38. And then we did the same computations we did on paper. So first we obtained angle B, which was 88.1. Next we obtained side C, which turned out to be 3.08, as you can see. Next we obtained angle C, which was 53.9. And finally we obtained the area, which was 6.15. And as you can see, this is reflected here in the triangle. I'm going to be presenting scenario SSS, or side, side, side. We begin the process by solving for the unknowns in the triangle, which are in this scenario all of the angles. Our givens are all the sides, so side A, which is 13, side B, which is 18, and side C, which is 21. Since we have all of our sides, the best way to find the angles is using the law of cosines. The law of cosines states that c squared equals a squared plus b squared minus 2ab cosine of c. Now since we are solving for angle A first, we use the alternative formula, which is a squared equals b squared plus c squared minus 2bc cosine of A. We want to find angle A, so we get cosine A on its own side and solve for it. This gives us cosine A equals b squared plus c squared minus a squared divided by 2bc. Then we plug in our values and we get cosine of A equals 18 squared plus 21 squared minus 13 squared divided by 2 times 18 times 21. After simplifying, we get cosine of A is equal to 0.79. We use the inverse cosine to get angle A by itself, and we get 37.8 degrees for angle A. Now we use the same process for angle B. We use law of cosines, and after isolating for cosine B, we get cosine of B equals c squared plus a squared minus b squared divided by 2ca. We plug in the values and we get cosine of B is equal to 21 squared plus 13 squared minus 18 squared divided by 2 times 21 times 13, which becomes cosine of B equals 0.52 after simplifying. We use the cosine inverse again and we get 58.7 degrees as our angle B. Now that we have two angles in our triangle, finding the third is very simple. Since all the angles in the triangle should add up to 180, we can use the equation 180 minus the sum of A and B. This becomes 180 minus the sum of 37.8 plus 58.7, and angle C is 83.5 degrees. One way to check that all the angles are correct is to add up all three angles, and we should get 180 degrees, which we do. We have solved for all the unknowns in this triangle, and the last step is to find the area. We can use the formula K, the area, equals the square root of S times S minus A times S minus B times S minus C. And S equals 1/2 times A plus B plus C. First, we solve for S by plugging in our givens. So we get S equals 1/2 13 plus 18 plus 21, which simplifies to 26. Now that we have S, we can go back and solve for the area. We plug in all of our values. So K equals the square root of 26 times 26 minus 13 times 26 minus 18 times 26 minus 21. And this will simplify down to 116.28, and that is the area of our triangle. We then went into GeoGebra and plugged in all the values in to create our triangle. So we started with the givens. So side A equals 13, side B equals 18, side C equals 21. And then we plugged in the equations that we used to find all the angles. So here's B, C, and A. And we can see these showing up here in the triangle. And then we put in S equals 26. And then we plugged in the area equation, and just we used GeoGebra really to just check our work. And yeah.